time for another example of using partial fraction decomposition. This one's a little bit different because we're actually going to have three different factors in our fractions. If you factored this, you would have x times x plus 4 times x minus 3. So that means I have not just an a and a b, but I'm going to have an a, b, and a c in this problem. So it's going to be a little bit more complicated, but it still works in a very similar fashion as all the other problems that we have done. So you set it up just the exact same way. There's your a, b, and c values. I'm going to go and I'm now going to make my common denominator. The way I have to do this, so for example, letter a here still needs to be multiplied by both x plus 4 and x minus 3. So I would need to do that on both top and bottom for this first fraction, x plus 4, x minus 3. B already has the x plus 4. It needs to be multiplied by the other fractions, the x and the x minus 3. Again, on both top and bottom. C needs an x as well, but it needs x with x plus 4. And again, you do it to both top and bottom. So when we combine all those together, the way it's now going to look is my denominator would have the x plus 4, the x minus 3, just like we want. My first guy, well, I might want to FOIL this, make this a little easier. X squared plus x minus 12. Hey, that should look pretty familiar, kind of similar to what we had there at the beginning, just without the x factor. So I'm going to have a times x squared plus a times x minus 12a. With b, I'm going to have a bx and a minus 3b. And I'm running out of room, but I'm going to have plus a cx, and I'm also going to have a plus 4c. Give me a little more room here to be able to use it. Let's try it again. There we go. So cx plus 4c. So the only difference between this problem and the other problems now is I'm going to have a bit of an extra step here because I now have to go and make not one, not two, but three different equations this time. So my first equation will be now with x squared, and then x, and then just the numbers, because we have extra things happening. So the x squared, there was 3 from my original problem here. My x would be 17 equals, and my number would be negative 36 equals. My values, the only thing that has an x squared is a. Well, that's really nice. That's the only thing here that had the x squared. Right? Wrong. Because I screwed up my factoring here earlier in the problem. It should have been, when I FOIL this through, it should have been bx squared. And it should have been 3bx. Same thing here, 3x squared and 4cx. So make sure you're checking your work as you go along there with that. So let's try to fix that again. Things with x squareds are ax squared and bx squared and cx squared. Okay, cool. Now let's look at what has just an x. Just an x. Let's do that here. That would be a. And here's just an x with a negative 3b. So if I do, there we go, negative 3b. The other thing with just an x is a plus 4c. So that was that right there. The only thing that's left, because we already took care of this cx squared, the only thing left that we're going to have is this value. That's the only one that has just a number in it, and it's negative 12a. So there's a system of 3 equations. This looks like it could be really difficult. It's actually not too bad, and here's why. Usually, not always, but usually, one of these equations is very easy to solve. This last one should be very simple. If I just divide it by negative 12, I know now immediately that a will be equal to 3. Well, that's cool, because now I can go and plug that into these other equations. So 3 would now equal 3 plus b plus c. It would also then mean that 17 is equal to 3 minus 3b and plus 4c. Well, I can simplify those even more. Move the 3's to the left, and I get 0 equals b plus c. And I also would get 14 equaling this negative 3b plus 4c. And this is fine because now I have just a standard equation again like I've done before. I can multiply this top equation by 3, would give me 3b and 3c. 3 times 0 is still 0. And now I can add these equations together very easily. So I would have 14 is going to equal 7c. Divide both sides by 7 gives me c equals 2. And I would now go back to my original equation, plug in my a value and my c value so I can find what's left for b. So I have 3 equaling a plus b plus c, which is going to leave me with -2 equal to b. And there you have it. As soon as you finish up your problem, which the way you finish it is just to plug back in your final values. So a was equal to 3, so it's 3 over x, plus b is -2, so -2 over x plus 4, and finally c is +2 over x minus 3. So there's your example of how to solve using partial fractions when you have 3 factors on the bottom.